Hello and welcome back to my channel. Today I'm going to be doing a tutorial on how to do the discriminant. But before I get started, if you want me to do more math tutorials videos, if you want me to do them potentially more often, then subscribe, hit the subscribe button, like the video, and yeah, let's get straight into how to do the discriminant. And I have lost my wiper. But yeah, let's get straight into the video. Okay, so the discriminant refers to a particular section of the quadratic formula, which we should all know off by heart by now because we will need to for the exam. The quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. The part of this formula which determines whether your curve is going to be, or whether it's going to be solvable or not, is called the discriminant, and it is the bit inside the square root. That is the discriminant there. So that is b squared minus 4ac. That is the part we're going to be looking at quite a lot in doing these questions. So there are three different types of curves. Not different types, but three different ways curves can look. This one, it goes through the x-axis twice. This one, it goes through the x-axis once. And this one, it does not go through the x-axis at all. So we can use, or the discriminant tells us like how each one is going to look. So in this first one here, well, I'll number them all. In this first one, b squared minus 4ac is greater than 0, which means that whenever you take the square root, say it could be the square root of 4, you get, that'll be plus or minus 4, so you get x equals plus or minus 2, so you've got like 2 and minus 2. This one here, b squared minus 4ac equals 0. That means that your square root is going to be 0, which means it could be like 4 plus or minus root 0 over 2. So your answer is 2. So that's 2. In this case it's 0, but there. Then in this one, b squared minus 4ac is less than 0, so you take the square root of like minus 71, which you can't do. Therefore, it does not cross the x-axis at all. Okay, so now for our first question. The question is, show, so that means you've got a proof, show that x squared plus 3x, this page I'm looking at is really not well printed, it's hard to see. So that x squared plus 3x plus 5 is greater than 0 for all values of x. Okay, let me see. Oops, I'm great at this, aren't I? Right, let's just get that down. Okay, so we want to see that this curve is above x for all the values. We use the discriminant to work this out. So b squared minus 4ac, we know that it has to be, or we want to work out what the discriminant is. We don't know what it is yet, but we need to know that it's above 0 for all values of x. So we work this out. 3 squared minus 4a, which is 1, 5. This is equal to minus 16. Now, minus 16 is less than 0. Therefore, if we sketch our curve, it's going to look a little bit like that. Now, we can obviously work out what our curve actually is. Our curve is x squared plus 3x plus 5. Wait, hold on. That's not 5. sorry, the 5 button is a bit risky in this. 5. Okay, and we get imaginary numbers. You can see the I is there. Means this is correct. So then just to prove that it is definitely all greater than 0, how you show that on the graph. Here's our x equals 0 line. We're gonna, and that's our y equals 0 line. Not x, it's on the x-axis, but y equals 0. So we are shading in y is greater than 0, and you can see that the entire curve is in that region of y is greater than 0. Therefore, we can work that out. So that's that question. Let me see. Sorry, I'm still a bit sick. This is my life is not going well. Okay, prove so that the inequality. I'll say prove that 3x squared plus 13 is less than 12x has no real solution. No real solution indicates that b squared minus 4ac with the discriminant is going to be less than 0. So what we do is we rearrange our equation to get 3x squared minus 12x plus 13. We work out the discriminant, so that's 12 squared minus, will cancel out whenever you square it. 12 squared minus 4 times a times c. I cannot work that out in my head, so let's use the calculator. We have 12 squared minus 4 times 3 times 13, and you get minus 12. Minus 12 is clearly less than 0, so if we were to draw a curve, here's our axes, it would look like this, and there is no real solution, so that no real solution. And that's that question done. These ones are easy enough so far. These are just kind of proofy questions to get you going in using the discriminant. Okay, let me see. Let's find a hard one. Okay, I'm gonna quickly find a question and then we will come back. Okay, so our next question is, we have our equation 4k plus 1 x squared minus k plus 10 x plus 2k is equal to 0. And the question is, if it has a repeated root, find values for k. So k in here is obviously going to be some answer, and if it has a repeated root, it can only be a certain number of answers. If you see repeated root, that should automatically make you think b squared minus 4ac needs to equal 0. So we work out the discriminant of this by b squared, so that's k plus 10 squared minus 4 times 4k plus 1 c, which is 2k. We're looking for this to equal 0, so now we expand. K squared plus 20k plus 100 minus 16k minus 4. And then that's upon 2k equals 0. Sorry, I changed the sign because I took the minus outside. K squared plus 20k plus 100 minus 16, 32 k squared minus 8k equals 0. Now we collect our like terms. Minus 31k squared plus 12k plus 100 equals 0. Now, if any of you watch my live stream, you'll know that I am awful at factorizing, so I'm gonna rub this out. We have obviously run out of room in this page, so I'll go up to here. Okay, so let's you know what, we'll use the calculator. It's much easier, even though it takes about an hour to find it. Okay, we have minus 31, 12, and 100. And our answers are 2 and minus 50 over 31. And those are your values of k. Because you have worked it out, you've worked out the discriminant. For the discriminant to be equal to 0, k must be those two things. Therefore, that's what k is. You can put that into the equation and check, but it's fine. Basically, if you put k into the equation, solve the quadratic you should get the same number, as in your root should be like the same, just x equals one thing, repeated root. So yeah, that is that question done. Now for a slightly harder question, we have cx squared plus 4c plus 1x plus c plus 2 equals 0. Show that there is no real value, so we're showing no real value for c if it has a repeated root, for c if repeated root. Now, repeated root, we're going, okay, what does that mean? b squared minus 4ac is equal to 0. So, what we're going to do is we are going to work out the discriminant for the repeated root, which is 4c plus 1 squared minus 4. A is just c, and then c plus 2 is c. Whenever this is equal to 0, whenever we expand, we get 16c squared plus 8c plus 1 minus 4c squared minus 8c like 0. 12c squared plus 1 equals 0. Then we get c squared, 12c squared equals minus 1, c squared equals minus a 12th, and obviously you cannot take the square root of a negative. No real solution. If we were to plot that on a graph, just to prove, we would draw out our extremely amazing graph. And if we want real values for c, we are looking for y equals 0. But as you see, this line, this curve does not cross y equals 0, therefore no solution for c. So that is one of the hardest easy questions. There are some awkward questions that I will do now, after I find them, of course. So that is kind of part 1 of the discriminant, which is all to do with your curve crossing the x-axis, but there's more. Of course there's more, it's maths, there's always more. What if we are now talking about curves meeting lines, curves meeting curves, curves meeting cubics, things like that. You can use the discriminant to work out if this is your situation, so that's the tangent, 2 points, or this is your situation here. So we use the discriminant very similarly to our last example. This will happen if whenever you equate, so equate, that's your first step, equate, and then b squared minus 4ac is greater than 0, you'll get this. B squared minus 4ac equals 0, you'll get this. And b squared minus 4ac is less than 0, you get this. So it's pretty much the exact same as the other one. However, instead of the y-axis being 0, you have to equate your two curves or lines to then see whether they will actually cross or not. Now, you may be thinking, if they don't cross, how can I equate them? And that's just part of how it works. That's just part of the process of getting it right. So, straight line, we have y equals 3, 2x plus 1 meets the curve. Meets the curve. Now this should start to ring bells. Meets the curve. Y equals k x squared plus 2. By using the discriminant, determine the range of, so we're looking for range of values for k. Now, this could mean this, or it could mean that. Both of those meet the curve. Therefore, we're going to be using b squared minus 4ac is greater than or equal to 0 to work it out. So let's start into the question. So we're looking for the range of values for k. I'll just rub that out. We just need our two equations. We're going to equate them. Nope, that is wrong. Kx squared plus 2. Then we expand and collect. So we have 6x plus 3 equals kx squared plus 2k. Bring it all over to one side. Kx squared minus 6k plus 2k minus 3 is equal to 0. Now we have our quadratic that we can now do the discriminant to, of course. What else are we going to do? So b squared minus 4c is greater than or equal to 0. 6 squared minus 6 squared minus 4k 2k minus 3 is greater than or equal to 0. Then expand that out. 36 minus 8k squared plus 12k greater than or equal to 0. Now I want our 8k squared to be positive, so 8k squared minus 12k minus 36 is less than or equal to 0. Now we have a quadratic which you can actually divide by 4, but I'll leave it. Whenever you factorize, you get 2k plus 3 k minus 3 is less than or equal to 0. So you get k equals minus 3 over 2 and k equals 3. Now whenever we draw our graph, we know that it's to be less than or equal to 0. So that is this bit here. This is 3 and this is minus 3 over 2, by the way. So we know that k is less than or equal to 3 and it's less than or equal to minus 3 over 2. So that is how you do one of those questions, which is takes a lot longer and it's a lot more complicated than. So that is most of the questions you can do with the discriminant. Look at that, wow, I'm so amazing. Yeah, so that's the discriminant. Thank you for watching, and I'll see you all the next time. If you did enjoy this video, hit the like button. Why not subscribe? I try to do these as much as I can. And I will see you all in the next one. Bye.